Hello. Today we are going to use our knowledge of the trigonometric angle addition identities to find out what the tangent of the angle 7 pi over 12 is. Now, if you think back to the unit circle, 7 pi over 12 isn't a terribly familiar angle, and you probably don't know the sine or cosine or tangent of said angle by heart. However, and I'm going to pull up the tangent angle addition postulates. Let's just pull those up. We know that the tangent of, it's an interesting color, some angle alpha plus some angle beta is going to be equal to the tangent of alpha plus the tangent of beta divided by 1 minus the tangent of alpha times the tangent of beta. Alright, so how can that help us? Is there any way we can break 7 pi over 12 down into two angles that we are familiar with and that we could perhaps sum to get the angle that we desire? So I'm gonna switch back to a nice purple color. So 7 pi over 12. Well, we can probably take out 3 pi over 12 and 4 pi over 12 because those seem like they might be helpful. Let's see. So we know that the tangent of 7 pi over 12 is going to be equal to the tangent of, 3 pi over 12 plus 4 pi over 12. That should be about right. 3 pi over 12 plus 4 pi over 12. And what are those angles? Let's simplify this even further. Those together are going to be, those separated but simplified, that's going to be the tangent of pi over 4 plus the tangent of pi over 4 plus pi over 3. All right, and those are familiar angles, right? Pi over 3 is 60 degrees, pi over 4 is 45 degrees. We should know the tangents of those angles, or at least the sines and cosines from which we can derive the tangent pretty well. So now let's start to actually solve this. So how would we put this into our formula for the tangent of two added angles? Well, we have the tangent of pi over 4 plus pi over 3 should be equal to the tangent of pi over 4 plus the tangent of pi over 3 divided by 1 minus the tangent of pi over 4 times the tangent of pi over 3. Now all we need to do is remember what the tangents of pi over 4 and pi over 3 are. Well, I'm going to even separate this out by a box. Even if you forget the tangents of these angles, you should probably be able to remember the sines and cosines. In fact, you definitely should. So we know that the tangent of pi over 4 is equal to 1, right? Because it's a 45-degree angle. We know that the sine of pi over 4 is equal to square root of 2 over 2. Oops. Square root of 2 over 2. And that the cosine of pi over 4 is equal to square root of 2 over 2. Therefore, tangent is sine over cosine, so we have a tangent of 1 for the angle pi over 4. What about pi over 3? Well, that's 60 degrees, so what's the sine of pi over 3? Sine of pi over 3, we know that that's going to be equal to the square root 3 over 2, and we know that the cosine of pi over 3 is going to be equal to 1/2. So what's sine of pi over 3 divided by cosine of pi over 3? Well, these 2's are going to cancel out when we divide, so the tangent of pi over 3 is going to be equal to the square root of 2. All right then. So if we pull this back over, let's substitute those in. I'm going to go back to the color I used before. Let's just do white. So we know that this whole thing up here is going to be equal to, we just plug in the values that we know, that's going to be this here and this here. So we're going to have tangent of pi over 4. Well, that's 1 plus tangent of pi over 3. Well, that's square root of 3. Sorry, did I write square root of 2? It should be square root of 3. My bad. Divided by 1 minus the tangent of pi over 4, which is 1, times the tangent of pi over 3, which is square root of 3. What does that give us? That's going to give us 1 plus the square root of 3 divided by 1 minus the square root of 3. And I'm just going to say that that's our answer, because the square root of 3 is something that I'm not going to write out here for you. I'm not currently using a calculator, but if you have a calculator, you can find out the value of this in decimal. But what we have done is we have found the tangent of this angle based only on our memorization of key terminal points on the unit circle and without using a calculator. And we could easily approximate the square root of 3 without using one either. I hope that this was helpful. Thanks for watching.